Good morning, friends. Welcome to Multiverse, and this is a discussion which is live. And today we have a very interesting subject to discuss. So, thank you for joining me live in this session across all social media platform. And what is that we are going to discuss today? Well, it is about what we have been seeing in the movies. It's about falling into a black hole, and you must have seen that in the movies. They show that the spacecraft or things are falling and then getting stretched and then eventually dying a painful death. But is it really true? Does it happen that way? This is what we are going to discuss in today's program. Friends, in order to understand what really happens when you approach a black hole, we need to understand the black hole itself. How the black hole is, what it is, what are the properties, etc. So, I will actually answer the question that we want to discuss today, but let's understand what is black hole. Black hole is a infinitely small object. It is so small that you can't even measure the smallness of black hole. It is so small. So there are many infinites that are associated with this object called black hole. For instance, it is spinning more than the speed of light. When the matter is falling into black hole, the matter changes, the direction of space and time changes, and time acquires the position of space, and space becomes time. So it reverses the space time, and therefore there are many such contradictions. It is very heavy in terms of mass. It is very, very huge, and it is so huge, it creates a huge amount of gravity that even light cannot escape the black hole. So if you see a light beam passing by, you will see that it will be absorbed by black hole and it is going to disappear forever. So the other contradictions that it brings is what happens to the matter which falls into black hole after it has fallen into the black hole. And the center of the black hole is also known as singularity. The singularity is an object which is very, very hard to understand and also harder to describe. And it is similar to what the universe was at the time of Big Bang. So it is a very, very strange object, very heavy. The only interaction black hole has with the rest of the space nearby is by way of gravity, which creates attraction towards the black hole. It pulls things into the black hole. And since it has the attraction, people are talking about falling into black hole. And since there are a lot of contradiction to the laws of physics, we will understand why it is not easy to fall into the black hole. By the way, we are live, friends, and if you want to interact with us, you can send your messages. Your messages will flash live here on the screen, and I will take up your comments. Now let's change gear. It is impossible to see the black hole because it does not emit any sort of radiation. The gravity of the black hole is so huge that it does not allow any sort of activity to escape from the black hole once it has fallen. But we also have seen the picture of the black hole. Recently, scientists managed to take the picture of the black hole. We are able to see the black hole because of the accretion disk. Now, the accretion disk is formed of the material which is trying to fall into black hole. And say, for example, some dust or some gas come very close to the black hole, it gets pulled because of the gravity. And when it gets pulled into accretion disk, it starts rotating because there are no straight motions in the universe. We all know that. So it starts rotating. And when it starts rotating, it starts colliding and rubbing against each other. And something very strange happens. And since this rubbing happens, the accretion disk actually heats up and start to produce a lot of temperature, a lot of magnetism by itself. And you can see that the black hole is in the middle of the accretion disk, But the accretion disk itself has a lot of different properties. For instance, the material is in the accretion disk is moving almost one third the speed of light, very very fast. To achieve even 0.1% of the speed of light, it requires a lot of power. So you can imagine that the accretion disk is being powered by the gravity of the black hole, and it is giving some of this power and converting the angular momentum, imparting the angular momentum into the material which is rotating around the black hole. And while rotating, it actually generates heat. How much heat? How much hot it is? So how much is the temperature? The temperature is so high, it is 100 times more hot than the core of the sun. So it's very very hot, very moving very rapidly, and because of this, the accretion disk makes it possible to watch the black hole, to see the black hole. Otherwise, black hole, if there is no accretion disk, it is impossible to see the black hole, because it will not have any sort of interaction with the surrounding areas other than the gravity. So if there is a black hole wandering around nearby, we will not be, without an accretion disk, we will not be able to see that until it comes very close, and then we will be doomed, and the black hole will suck the Earth and the solar system into it. So accretion disk is something that makes it possible. Well, while the motion is also there, and whenever there is a motion, it generates a lot of electric currents and a lot of magnetism. But the black hole itself is not a stationary object. It keeps wandering around. It also has a rotation. So even though black hole is a very simple object, but it has other properties, like it has a spin, and it may have some charge. We can't say for sure, but since it generates some sort of magnetism, so scientists assume that it may have a charge. And of course, the third property is the huge mass, which runs into at least 20 times the mass of sun and goes up to billions of masses of sun. And this mass which the black hole has generate the power of the black hole, and generate it's like an engine. So heavier the black hole, the bigger energy it has, and bigger accretion disk it is able to accumulate more material, and it powers that material while it is rotating around the black hole. And because of this magnetic and spin, the material from the black hole find it difficult to escape. And because even in the accretion disk, if there is a lot of heat, a lot of kinetic energy, the kinetic energy makes the matter to expand. But there is so much gravity which is being pulled inside the black hole that the material or the energy which is, or the explosions which are being produced in the accretion disk, find it very difficult to escape. So over time, the heat and the temperature builds up, and there are a lot of magnetic particles like gamma rays, and there are a lot of electromagnetic radiation which also build up, like X-rays. So the weakest point in a black hole combination of accretion disk is the pole on which the black hole is spinning and the entire accretion disk is spinning. So this is where the jets of this superheated plasma escapes like a laser beam, and the amount of matter which escapes is less than 0.1% of the entire matter which is rotating around black hole. And many black hole does not have these jets, but many of large ones, very energetic ones, have these jets coming from both sides of the black hole. And what are these jets? Well, these jets are basically the electromagnetic radiation, which also has the visible light, and also has the gamma ray, and very very intense radiation comes out, escapes. That energy which builds up in the accretion disk escapes out into space through these jets. And these jets are so energetic and very very narrow, because of the gravity and the magnetic forces which is acting upon the matter in the black hole system. When these jets are escaping out, they are imparted a very narrow near light speed and also it is imparted a very narrow place in the universe, but very energetic. So these jets which are coming out from both sides of the black hole, they have the potential to travel for millions of light years without bending, until unless they encounter another black hole somewhere in some other part of the universe. But they are like laser beam, very high energetic laser beams, and they have the ability to wipe out uh, the life on any unfortunate star which drift near these jets. And most of these jets we are not able to see, but if these jets are pointing towards Earth, we will be able to see. So if there is a nearby black hole and we are in the path of these jets which are coming out from the poles of the black hole, the chances are the entire life will get wiped out in less than 1 second, because these are planet-sized laser beams which are coming out, very energetic, very powerful laser beams. And there is no other power other than the black hole in the universe to change the direction of these beams. So in case we encountered these jets close by, from a close by black hole, the chances are that life will get wiped out. So right now we are discussing the properties of the black hole, and since the matter is moving very rapidly inside the accretion disk, and near the black hole, the motion is almost the at the speed of light, because when the matter is spiraling downwards and trying to fall into the black hole, the speed picks up as it keeps coming towards the black hole, and at the very close proximity of the black hole, the matter is almost moving at the speed of light, and that is where the contradiction happens. And as you know that there are several contradictions and paradox in the black hole. Number one is that it bends the space and time so much that the space becomes times and time becomes space. The space and time flip their places inside the black hole. So that is one paradox. Second paradox is what happens to the material which falls into it, because once the material fall into the black hole, it is going to disappear forever, and that is against the laws of physics, because in the laws of physics the total net conservation of energy remains constant in the universe. So if a hot object give its energy to a cold object, the net energy which is hot and cold will remain the same before this reaction starts. So this kind of reaction is calculation is not possible when it comes to black hole, because black hole takes the energy from the universe and makes it disappear forever. So this is one big paradox with when it comes to black holes. And similarly, there are other paradoxes. There are several actually. For example, infinity. What is infinity? Infinity is something which is so small, so powerful, and so on and so forth. So it is very difficult to describe infinity, and there are several infinities associated with black hole. So now let's go back to the paradox that we are dealing with. If the material in the accretion disk is moving so rapidly, nearly at the speed of light, in the middle, in the last portion of the disk, that visible portion of the disk, then again there are paradoxes, because as you increase your speed, there are properties which are very much associated with the speed of the light itself. And as we know that there is nothing in the no particle, nothing is in the universe that can exceed the speed of light. So because of this situation, the matter is put in a flux. That means it is now rapidly going towards the black hole, and also the speed is increasing, so much so that it is near the speed of light. But laws of nature says that you cannot exceed the speed of light. So the matter is, in the flux at this point. The other paradox that happens here in this position is that when the speed of light is attained, the mass of the particle becomes infinite. So since that is again a second paradox, so when you're trying to when you're falling into the black hole, you are subjected to these paradoxes, and scientists do not know what happens really How can you overcome these paradoxes? And since you don't have a mechanism to overcome these paradoxes, the matter at the very edge of the accretion disk is unable to increase the speed, and therefore it is unable to fall into black hole. And that is the logical conclusion that I have come to. And if you disagree, send in your comment and we can have a discussion live right now. But this is my 2 cents on this subject. And since the matter is still in the part of the universe which is visible to us, and it is moving so rapidly that it is moving at the 99.99% of the speed of light, but to even cross and become 100% the light, it has to cross these paradoxes. That means, first of all, you have to exceed the speed of light, or even attain the speed of light. Second is your mass will be infinite. So it keeps increasing speed and it keeps slowing down over there. So that is why what you have seen in the movies and Hollywood movies and all different types of movies globally, where you see that the matter is falling into the black hole and you enter the black hole and then you get into the fourth dimension, etc., etc. They show that there are aliens living inside the black hole and all that. So while trying to understand what we have been saying in the movies, I have come to the conclusion that it is impossible to even fall into a black hole. I mean, it is impossible to even reach the boundary of the black hole in a one piece. That is one. And even if your atoms of which you are made of, they are unable to cross that boundary, the event horizon as we call it, because they will not be able to violate the laws of physics at that point. So they will not be able to fall inside the black hole. So this is what I feel on this subject, and I feel that whatever you have been seeing in the sci-fi movies or special effect movies are not really true, because it is impossible to get dragged and fall and get into another dimension, maybe some other parallel universe through black hole, because you cannot even cross the accretion disk, which you have to cross first before you reach the event horizon. So friends, do let me know what you feel about this subject. And as you know that I respond to each and every of your comments, so I eagerly await your comment, and I will meet you again next Thursday in Multiverse. As always, thanks for watching and bye bye for today.